For today's conference, these are the following topics we're going to be discussing. Starting with the scores on the actual test. So I went through and found what the class median was. It was 75%, and then Canvas kind of did the rest for me. It found the class average, the high, the low, and then the standard deviation. So the scores are kind of normally spread. You'll see that it's pretty much in this entire area right here, where the majority of the scores were like in the 75 range. Learning targets, I believe that we mastered, meaning that more than 80% of students got these questions correct, or the majority of the points for these questions. It was actually most of the test, which I found surprising when I really looked through and did an analysis for everything. I would say the conic sections, you guys definitely really understood. It was pretty clear to me that all of you guys, for the most part, were able to identify key features, graph conics, identify what type of conic it was, and then also use key features in order to find the equations in standard form. So all of that you guys were pretty good at. Applying circle properties, inscribed quadrilaterals, the tangent, central angle, inscribed angle, unless it was a careless error that I noticed. Also, I saw that you guys did well on that. And then 14 and 17, the radian and degree measures, like if you're given one measure, can you find its equivalent measure or identify one that is not equivalent? And then lastly, the true and false statements on radians, you guys did pretty well on also. Where I started to notice us struggling was surprisingly the volume section. A lot of us missed questions 1 and 2, and I think, yes, they were more difficult volume questions. And I also think that because it was at the beginning of the test, you guys rushed through it and you weren't even reading the problem carefully. And the reason why I know this is because I know all of us know the difference between a sphere and a circle. And so many of us got the first question incorrect because we set the volume of a cube equal to the area of a circle. And I know that that's just us kind of rushing and being maybe a little bit stressed out at the beginning of a test. Then the truncated cone question, I know that that was challenging. We are going to go over that together, but that's another commonly missed question. And then lastly, 15 and 16, like almost 80 to 90% of all my students missed that. I could probably count 10 or less students that got those 2 questions correct. For the most part, every other question that I had not discussed, it was kind of a mix. Some of them you left blank, maybe due to time. Some of them you got partial credit, but these questions here are the ones that were most commonly missed. So now talking about the test curve. I already gave you partial credit for questions 1 and 2, as long as you knew the correct volume for each of the questions. Like if I saw you on your scratch paper write down the volume of a sphere was 4/3 pi r cubed, you knew the volume of a cube was the side length cubed. You set them equal to one another, but you made some sort of algebraic or calculation error, which is a ton of people. Then I gave partial credit. Same with number 2. If you knew how to find the volume of a cone and subtract it from a volume of a smaller cone, I gave you partial credit. So I'm not going to take that into account when I'm curving the test because I already gave partial credit for 1 and 2. 15 and 16, I didn't really give any partial credit for. You either got the question correct or incorrect. So I decided to curve the test for those 2 questions. After hearing feedback of not having enough time, I really think that the reason why most people missed these is not because you didn't know how to do it, but it's more because you probably ran out of time since those were the questions at the very end of the test. So with that said, the test scores are going to be out of a raw 90 points instead of the 100 in Aries. So on Canvas, it no longer allows me to adjust any scores because the tests have already been graded. And once the tests are graded, Canvas, unless I manually go in to every single test, it won't let me do anything. So instead, on the gradebook for Aries, I'm going to adjust it to be out of 90 points instead. It's still going to hold the same weight. So it says here, if you got an 80 out of 100 on your Unit 8 test, it's now going to appear as an 80 out of 90. So in terms of a percentage and how much weight that holds toward your grade, it would be an 88%, and the system is going to adjust it to an 88.88 out of 100. By doing this, I think the raw score of a 73 average would bump up to an 81% class average, which I think is fair considering I did look back at my previous years for the Unit 8 exam. And obviously that was not online, but still the average varied and ranged between 78 and 85 from the last 3 years. So I believe that adjusting it to an 81% average is fair. This is the only way that I'm able to also still reward the students who got 15 and 16 correct. I don't want to take those questions out because it would potentially hurt some students that did well on those questions. So because you'll notice here that, of course, we have students that got over 90%, there are students that have over 100% on this test as well. I think that answers all the questions regarding like the analysis of this like question breakdown as well as the adjustments to the score. But are there any questions before I start going over the actual test questions? Again, you can have your mic turned on if you have any questions for me. Okay, it does not look like there are any questions coming in, so let me start going over some of the problems. Every single student in this class had the same type of question for number 2. The only difference was that the numbers were adjusted. So you may not see 9 centimeters, it may have been a height of 11 or 13. So you have 2 truncated cones, cones whose tips are cut straight off. So if I have a cone here, and for those of you that did the optional review, you had a very similar type of question about truncated cones, and you have this part that was cut straight off. That's this top portion of the cone. And there's 2 of them, so we know that I just have to find the volume of one of those truncated cones and multiply it by 2. I am given the height of the truncated cone in the diagram as 9 centimeters, but the original cone had a height of 13 centimeters. So this entire cone here had a height of 13, and the smaller, or the larger cone, I guess, had a height of 9, and then the smaller portion here had a height of 4.5. Then the height given, the radii, this is 6 centimeters, and then the smaller one is 2 centimeters. What is the volume to fill the hourglass? All you had to do was take the volume of the larger cone, subtract out the volume of that small cone that was cut off, and then multiply your final answer by 2. So I think we all know how to find the volume of a cone. It's the 1/3 area of the base times the height minus 1/3 area of the base times the height. This simply came down to you just knowing how to apply the different formula. 1/3 times pi times the radius squared times the height of the largest cone was 13 minus 1/3 pi times 2 squared times the height of this was 4.5. And once you evaluate this, simplify, multiply by 2, then you would get your final answer. 13. Oh, sorry, yes, I read the question wrong. This is 13.5, so that's just 13.5. Oh yeah, so that is 4.5 still. Thank you, Jimin. Okay, so I think everything else is good. The 9, 4.5, 13.5, and yeah, so then you would just evaluate this whole thing and then find your final answer. And I think this one was just 312 pi. So you'll notice that the question itself wasn't that difficult. If you just drew out the diagram, you would have gotten the correct answer. I think some of us just kind of rushed through this question. The next question I wanted to discuss was this one here. You already know from this diagram that a times x is equal to k times n. Of the 5 points that this question was worth, I think I gave 2 questions as long as you identified what the equation was. Then in number 2, how can you prove the equation you wrote in part 1? For the most part, there was only one correct answer, and it came from the video notes that you had watched. And I just wanted to show 5 different examples of what I got as an answer. So you might see your own on the screen in front of us. But these are just very common answers that I was receiving that are also good examples of what I was looking for. So I didn't even know you could insert a picture into a response, but a student went ahead and labeled all of the intersection points and then did an actual proof for me on how to go about this. So of course, for the most part, you are using similar triangles to answer this question. When you have 2 chords that intersect, we end up finding 2 triangles that are similar because these 2 angles are vertical angles. We have here an arc that is created by an inscribed angle. We have an inscribed angle here that opens up to the measure of this arc. And this arc also is the same as this inscribed angle, or this inscribed angle also creates that as well. So once we know that those 2 angles are also congruent to one another, then what we have here are 2 triangles that are similar by AA similarity, and therefore their side ratios are equal to one another. So once you set up a proportion, you're able to cross multiply and show that D times K is equal to E times J. Every single other response down here, 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 and here, they all pretty much do the exact same thing. I appreciated some students, instead of like actually inserting a diagram, for the most part had their work on scratch paper, which is also something that I was looking at while grading your tests. So again, this is what the answer to this question should have been. So if you're concerned or had a question about why you may have missed points there, this is what I was looking for. Moving on to question 11. I'm going to just briefly talk about this because majority of students got this question wrong, but I did give partial credit here. So they were both false statements, and of course I actually wanted you to correct both of them. This is just an example of answers or responses I was looking for. Inscribed angles on a diameter measure 90 degrees, since it's always half of the angle measure of the arc that it intercepts. So when you have a circle, this is the length of your diameter. An inscribed angle on a diameter would be something like this. That's an inscribed angle that opens up to the measure of this arc. If that arc is 180 degrees, this inscribed angle must be half of that, so 90 degrees. Any kind of response like that gave you full credit here. And moving on to letter B, why is this not correct? Because the statement simply just says a line drawn perpendicularly through a chord will go through the center. Some people even just drew a diagram on their sheets of paper for me. If I draw a chord like this, a chord is just having 2 of its endpoints somewhere on the circle, and I draw any kind of perpendicular line, it doesn't necessarily have to go through the center of my circle. It just says that the line is drawn perpendicularly. So the only time it goes through the center is when you bisect this chord. Some of you wrote a perpendicular bisector always goes through the center of the circle, so you would have noticed that you got partial credit for assuming that the statement said perpendicular bisector. I think we're okay on that. So I am going to move on to the next question. This question did not ask you to construct anything. It just said explain the strategy behind the constructions that you would perform. So instead of walking through exactly how I would have explained it, I just showed also some good examples of responses that I got from students. So here I would connect the line PA, draw the midpoint of PA, draw a circle with a midpoint and center as the diameter. So this is just explaining to me what the construction is. And then here, the 2 points of tangency from circle A to P would then be the intersection of the circle, and I just drew circle P. This is what I was looking for though. Like, why are we doing these constructions? So yes, it's nice that you told me the construction part. That was like the first 2 points. The next came from like what the purpose is of these constructions. I use these specific constructions because a tangent point is 90 degrees, meaning if it were on a circle, it would be an inscribed angle on the diameter. Therefore, it would make sense to draw such a diameter PA of the circle. So the reason why we even started with the diameter connecting P and A is because we wanted that to act as a diameter where we're able to find an inscribed angle whose endpoints are on the diameter that creates a 90-degree angles, which is how we can confirm that the point of tangency is perpendicular to the radius, or the tangent line is perpendicular to the radius at the point of tangency. You also see that same response in pretty much all of these. It starts off with how to actually do the construction, then explaining why they did that construction. Radii is going to be perpendicular to the line segments. And then since the tangent lines are perpendicular, a lot of these did have diagrams that came with it that I was able to follow if they were using different variables. Why are we doing this again? Tangent lines are perpendicular to the radius, inscribed angles measure 90 degrees. I wanted to know exactly what circle properties you were using when coming up with your response. Moving on to another question. This one I would say that almost nobody got correct. There were very few people that got this correct, basically people who got almost 100 on the test. So it says, given the circle has a radius of 6 centimeters, find the area of the shaded sector. So this is 6 centimeters, and the shaded sector, I don't know if it was confusing what the actual shaded sector was, but it was this. That's the only portion that was shaded. Everything else in the diagram was given to you to help you figure out what that area is. You actually had a homework question that was very similar. The only difference is that in your homework, you were given like a 90-degree sector, and then you had to subtract out a right triangle. This triangle example, though, was meant to be an easy one as well because you have an equilateral triangle and we had just finished a trig unit. So in this equilateral triangle, I know it's equilateral because, again, I have the markings. If this is 60 degrees and a triangle is 180, 180 minus 60 means that the remaining two equal 120, so these are both 60 as well. So now that I know that I have an equilateral triangle, all the side lengths are congruent, which makes sense because if this is 6 centimeters as the radius length, this of course also has to be 6 centimeters as the radius length. And now how do I find the height of the triangle? This is one of the special right triangle properties that we learned last unit. In half of an equilateral triangle, if this side length is 6, half of that would be 3. The height of this triangle is 3 times rad 3. So 3, 3 rad 3, 6. Hopefully this is coming back to you since it hasn't been too long since we learned this. The area of this triangle would be 1/2 base times height, which is 1/2 times the entire length of the base is 6 times the height is 3 rad 3. So the area of this triangle would be 9 rad 3 centimeters squared. Then, in order to find the area of just this little portion here, what I want to do is actually find what is the entire area of this shaded sector. So the area of a sector is always some fraction of the circle times the area of the whole circle. So the area of this circle would just be 36 pi centimeters squared. What fraction of the circle is this equivalent to? It's 60 out of 360, which is 1/6 of my entire circle. So 1/6 of 36 pi centimeters squared would have been equal to 6 pi centimeters squared. That's this whole highlighted section. To find just this blue shaded section, then from here I would subtract out the area of the triangle that we had previously found, 9 rad 3. And then you were asked to approximate this or round it to the nearest hundredth place. So 6 times pi minus 9 times rad 3 would have been about 3.26 centimeters squared. Again, the reason why I took this problem off when it came to your final score is because I think we all know how to do this question, but I also think that a lot of us just ran out of time because I would say 1 in 5 students actually left this question completely blank. And my guess is that you just didn't have time to answer it. This next question was also missed by almost every student or most students. And the reason why, when I was looking back at everyone's work, is because I think we also rushed through it and didn't fully read that we have an inscribed angle. So here I have an inscribed angle that measures pi over 5 radians. Find the length of the, the length of the arc, you're told, is equal to 3.84 pi inches. Find the exact length of the radius. So we know that the length of an arc is equal to, again, some fraction of my circle times the circumference of my whole circle. My unknown variable that I'm solving for is the length of this radius. I have everything else though. I know that the length of this arc right here is equal to 3.84 pi. But what fraction of the circle is this highlighted portion? There are a couple ways you can find it out. Of the people that got this correct, some of them actually converted this into a degree measure, then multiplied that by 2. Or if you know that this is the radian measure, that arc is going to be twice its measure, so that's equal to 2 pi over 5 radians. Again, doing a conversion from degrees will also give you the same result. This would be equal to 36 degrees, meaning that this is 72 degrees. 72 divided by 360 is going to be 1/5 of your circle. Same answer comes about if you do 2 pi radians, or 2 pi over 5 radians out of a total 2 pi radians is equal to 2 pi divided by 10 pi, which is also equal to 1/5. So again, whether you did a conversion from degrees or kept it in terms of radians, you would end up with the same result. It's just 1/5 of your total circle. So now, again, once you get to this point, the only thing left to do is solve algebraically for the length of r. You could divide both sides by pi. You can multiply both sides by 5 over 2. And that's pretty much how simple this problem was meant to be. 5 times 3.84 divided by 2 is equal to 9.6 inches was the length of the radius. This was another question that not that many people missed. I gave you full credit if you explained to me that you would use the perpendicular bisectors because we are trying to find a point that's equidistant to all 3 points. But I did just want to show you what the correct answer should have been. Again, if you got like Iowa or maybe North Dakota or even like upstate Nebraska, I gave you credit as long as you identified you would use perpendicular bisectors. I didn't really use or give partial credit at all. If you said angle bisectors, you actually do end up getting Nebraska as the same answer, but by saying angle bisectors, you did not get credit because you were not answering the question correctly. These are some examples of correct answers as well. What I was looking for in a response, where they should meet, that was important. These 3 somehow all got the correct answer. First, form a triangle with the points as vertices. We learned the center of a circumcircle is equidistant from all 3 vertices of a triangle. We know that it's found by connecting the perpendicular bisectors. To the best of your ability, found it was South Dakota. Because the 3 bisectors meet, that point is equidistant from the vertices of the triangle. Perfect explanation. They're all good explanations. First, draw a triangle, location of the vertices, construct the perpendicular bisectors, then find the intersection. The circumcenter of the triangle is equidistant from each vertex. The student also overlaid the paper and found it was South Dakota. Lastly, you could have even had a shorter response and still gotten full credit. I got this state by making a circumscribed circle by making 3 perpendicular bisectors. The point where all of the lines intersect is the best location to meet because it is equidistant from all 3 points on the map. Again, a shorter response, but still has all the criteria necessary in order to answer the question in full. Okay, so I think I went through every question I thought was important to go over. The rest of them, again, not too many people missed. And if you did miss, I thought that you were able to figure out the answers to the other questions. These were just the ones that didn't necessarily have an answer key either, especially these proofs toward the end.